Tonight on Catalyst, invasion of the giant jellyfish.
Fishermen here say the Sea of Japan is becoming a sea of slime.
And is coal gas the new black gold?
The coal rush in Queensland, turning farmland into factories.
G'day, welcome to Catalyst. The giant Nomura jellyfish can weigh up to 200 kilograms and be 2 metres in diameter. And in large enough numbers, they can devastate a fishing industry. Well, researchers are predicting a mass migration of these creatures from the East China Sea to the west coast of Japan. Dr. Mary-Anne de Macy went to the Sea of Japan to find out why this phenomenon occurs and if anything can be done to control it.
Oceans cover 2/3 of our planet. Beneath their surface lives the largest habitat on Earth. It's unique, but often fragile.
One of the biggest threats to our marine ecosystems is human activities.
There's now little doubt that changes in our ocean are having a profound impact on marine ecology. As many as 30,000 different species of jellyfish are poisoning and eroding the habitats of higher fish species. Now, sumo-sized armies of slime are descending upon the Sea of Japan.
It's really the big problem. The fishermen are crying with this phenomenon.
Without bones or brains, these evolutionary marvels have survived for over 600 million years. Now, researchers are hoping to unravel the mysteries behind their invasion. Here, I join Japanese scientists as they explore what's been dubbed the rise of slime. I arrive at a remote fishing village in West Honshu. This team of fishermen prepare to haul in their nightly catch. It's around 4 in the morning and we're heading off to the Sea of Japan. These fishermen are pretty anxious to see what their nets have snagged. These fishermen know they're about to come face to face with their enemy, the Nomura jellyfish. As the sun rises, so does the tension. They work tirelessly to reel in the nets.
Oh look, there's all jellyfish in the net.
It's obvious the jellyfish have returned for the season. Their onslaught threatens the livelihood of fishermen, bringing the industry to its knees. The Nomuras are choking marine life, stinging fish with their venomous tentacles.
This is one of the smaller jellyfish, but they can get enormous in size. Some are reported to be about 2 metres in diameter and weigh about 200 kilos. That's the size of a sumo wrestler.
As we head back to port, the fishermen say the worst is yet to come. Today, the fishermen tell me they're bracing themselves for the most catastrophic bloom of jellyfish in history. In peak season, around 500 million jellyfish drift through these waters every day. Until 2002, these gentle prehistoric giants were seen in sparse numbers. But the invasion has spiralled out of control. To solve the mystery behind the swarms, scientists must learn more about their behaviour. Dr. Honda works at the coalface of the jellyfish plague.
発信機、クラゲの行動を調べるための発信機をつける調査をしています。クラゲっていうのは魚や他の動物と違って大変体が柔らかいものですから、その発信機をつけること自身が 大変困難でした。
Satellite tracking provides information about the swimming depth of the jellyfish.
例えばその越前クラゲの遊泳する深度、そしてそのパターンを知ることができますと、操業する深度、そういったのどの深度が一番効率がいいかということが分かります。
The extermination of the swarms is the brainchild of the Japanese government. As fishing boats trawl through blooms of jellyfish, wire grills at the end of the nets slice them into pieces. But the scientists say this might make the problem worse.
The female has as many as 1 billion eggs.
Slaughtering the jellyfish will only disperse billions of eggs into the ocean, and when the conditions are right, the numbers explode.
Now, there are various theories on what's causing this explosion of jellyfish. Ironically, one of them points the finger back at the fishing industry.
We're taking out the small pelagic fish in the oceans. These are things like anchovy and sardine and herring. When we remove them from the ecosystem, we find less predation on the young jellyfish, and there's actually more food around for the jellyfish to eat, and so they increase in numbers.
As a result, the ecological switch in parts of our oceans has been flipped.
We end up with a system that was dominated at one time by fish, now being dominated by jellyfish. And we're starting to see that in Southeast Asia, the Mediterranean, the Gulf of Mexico, and off southern Africa.
Over the past 5 decades, a staggering 90% of big fish have disappeared from the ocean.
Industrialization and the increase of the population near the coastal waters is one of the reasons.
Pollution and runoff into rivers and oceans leads to an increase in the water's chemical nutrients. It's known as eutrophication.
And what we mean by eutrophication is nitrogen and phosphorus in fertilisers and sewage running in to Southeast Asian waterways. This leads to big plankton blooms, and it's then broken down by bacteria, and that uses up all the oxygen in the water, so you can form what's called oxygen dead zones.
The number of dead zones has doubled every decade since the 1960s.
These areas you could think of as almost like protected areas for jellyfish. Predatory fish can't go into those areas, but jellyfish can, and it's good habitat for the jellyfish.
This giant monolith is China's Three Gorges Dam, the world's largest hydroelectric power plant. It's been blamed for changes in water flows down the Yangtze River.
Here at the mouth of the Yangtze, there's been a reduction in the flow of fresh water, which has allowed salt water from the East China Sea to seep in. Now, this may be why scientists have seen a surge in the number of jellyfish around this area. And of course, from here, they migrate out to the Sea of Japan.
Around 50 kilometres off the coast of Japan is the remote island of Oki. I joined Dr. Otsu and Dr. Ue on their hunt for the Nomura jellyfish. It's hard to believe that beneath these lush green mountains and deep blue sea lurks the enemy. After hauling in a jellyfish, we head back.
Just below the umbrella, there's a gonad.
Dr. Otsu takes a sample of its gonads.
Male. Male? Male. Oh, he says male.
In the lab, he studies its reproductive life cycle. He's learnt that if their survival is threatened, they respond rapidly and their survival instinct kicks in.
彼らが元気なうちは少なくとも生殖巣というのは、未熟な状態のままなんですけども、傷ついて生きていけないと悟った時には、そこで急速に生殖巣を成熟させる。 そして、自分の子孫を残そうとする。
These are 3 weeks to 1 month old.
Wow, it's hard to imagine they become such a menace.
Yeah, that's right. They are very cute at this moment, but it becomes really giant or the monster half a year later.
Scientists know that warming oceans can trigger proliferation.
In the Chinese coastal waters as well as Japan Sea, we have a quite elevation of the seawater temperature. During the last 25 years, the temperature got elevated by 1.5 degrees Celsius. At higher temperatures, the polyp can increase their number more quickly.
If they can pinpoint what triggers a bloom, there may be some way of intervening before they completely dominate our oceans. Unfortunately, the jellyfish can't be used as a resource. Processing them isn't as commercially viable for Japan as it is for China and Korea. Though I did manage to find one restaurant that had jellyfish on the menu.
Arigato gozaimasu. Now, the locals say jellyfish is not such a popular dish, but I'm going to try it anyway. Chewy, but very tasty.
The Fisheries Ministry is even trying to win converts by publishing recipes which use Nomura jellyfish.
They've even got jellyfish dessert.
Until jellyfish blooms are kept under control, fishing industries and the marine ecosystem remain in peril.
There's no immediate answer since the causes are really multiple and based on our human beings' activity. So maybe we have to pay more attention to the ecosystem of the ocean and biodiversity as well.
I think the jellyfish joyride is a serious concern. So if we don't tackle it now, we are going to see more of these switches where jellyfish are taking over from fish and they're becoming the dominant marine life in some of these areas.
Have you recently become a father? Are you thinking of it? Well, congratulations, but that's not why we ask. Catalyst needs your help to find out about your health, happiness and hormones. All in the name of science, of course. Here's Jonica with our call to arms.
Pregnancy. It's all about mum, right? Well, not this time. Here at Catalyst, we're about to put the focus on fathers. We're currently filming a big fatherhood science special to be broadcast next year, but in the meantime, gentlemen, we'd like you to be involved. For our special, we're running some original research. We've teamed up with scientists to develop the first national survey of the impact of pregnancy on men. So, if your wife or partner is currently pregnant or you've just had a baby, please log on to our website and fill out the survey. Your answers will form part of our special on fatherhood in 2010. Come on, men of Australia, please join us. This time, it's all about you.
With the worldwide push to reduce global warming, coal has received particular attention. It produces significant greenhouse emissions. Well, for decades, researchers have been working on ways to extract the energy from coal without digging it up, which will have a lower impact on the environment. There's now a booming coal gas industry, which is not only cleaner, it also allows coal seams to be tapped that are either too deep for traditional methods or too gassy. Mark Horstman returns to his home in southeast Queensland to check out this technology that's ushering in a new coal rush.
The face of the Darling Downs is changing fast as agriculture gives ground to mining. In many paddocks these days, you'll find the hard hats of the coal gas industry.
I come to work every week and there's new people I've never met before. We're growing so much, and it's genuinely an industry that's got its time and its place, and it's happening now.
What's different about Queensland's new coal rush is it's all about getting the energy out of the coal without digging it up. This is a story about using coal for gas, and two very different ways of doing it. One is UCG, or underground coal gasification. It burns the coal underground. The other is CSG, or coal seam gas. It keeps the coal intact and sucks out gas instead. There are 5 CSG companies sinking thousands of wells like this across the countryside. Arrow Energy is one of them.
We do what coal miners do themselves when they're underground coal miners. They have to drain the gas out of their coal to be able to mine it safely. And effectively we're doing that and making a business out of that ourselves.
Over the last 10 years, CSG production has increased by more than 100 times. Most of Queensland's gas supply now comes from coal seams. It's 98% pure methane that builds up naturally in cracks and pores inside the coal. The methane is trapped under pressure from hundreds of metres of rock and groundwater lying on top.
Basically, we drill a hole. This well here is to 300 metres.
On the way down, the well is cased to stop leakage from aquifers it might drill through. At the coal seam, a cavity is reamed out with a rotating blade and lined with a perforated casing. A rotating screw pumps groundwater out of the seam and up to the surface.
So this is going 300 metres down to the coal seam and bringing the water up from there?
Yeah, we set the pump a little bit below the coal seam so the gas water can flow out and come to surface.
Releasing the water pressure releases the gas, so the rate water is removed controls the flow of gas.
Water comes out via this top tubing here, and the bottom tubing here is where the gas comes to surface.
Gas from 150 of these wells is compressed and piped to the nearby Braemar power station, where it's burned in giant jet engines.
These are open cycle gas turbines, and they're particularly good for being able to turn on and turn off relatively quick duration so that you can match the peak demand in the electricity market.
This 450 megawatt station powers about 150,000 homes.
We think that it's climate friendly in the sense that the emissions from this are half of from a coal power station.
While the gas is cleaner, there's a catch. At full production, this company alone will produce 50 million litres of water every day.
The coal seam gas companies have got one big problem: what to do with all that water and the salt that's in it.
Up to now, the solution has been to leave it on the surface in massive evaporation ponds.
Can I taste this water?
You can, yes.
What's it supposed to taste like?
Slightly brackish.
Yeah, fairly brackish, I'd say. How salty is that?
It's roughly, depending on the fields that it comes from, it's roughly 1,500 ppm through to about 8,500 ppm.
That's about 1/6 the salinity of seawater.
We're looking at treating the water to make sure that we minimise the impact of the water, particularly the salt, that will be left behind on the landscape.
It's not surprising that here, on the fertile soils at the top of the Murray-Darling Basin, farmers are sensitive about salinity.
Now we're seeing these gas companies bringing up millions of tonnes of salt, storing it on the surface, and the government hasn't got a plan for it. It's just, oh, we'll put it in the storage and we'll bury it and forget about it. Well, salt doesn't go away. It's there forever.
But what if you could leave the salt, the water and the coal where they are and extract more energy by converting the coal to gas underground? That's the promise of UCG. There are 3 pilot projects in Queensland. Carbon Energy is one of them.
UCG is very different from coal seam gas. Underground coal gasification extracts the energy in the coal itself, which means we can extract a very large amount of energy from a small footprint. In fact, 20 times the amount of energy you would do from a similar coal seam gas extraction process.
I've come to this paddock near Dalby because Carbon Energy is trialling its UCG technology here. Rain, hail or shine, 24 hours a day for 100 days.
It doesn't look like much, but I'm standing in the middle of a coal mine, one of the only ones of its kind in the world. 200 metres beneath my feet is a coal seam that's 30 metres wide, 8 metres deep and runs for 600 metres down that way, where it's extracted at this end through these pipelines after the coal has been converted into gas.
What's the pressure down there?
It's 17.9, George.
Okay, I've got a 7.5 and it's steady as well, so we're probably okay.
John Wedgwood heads the team putting this underground reactor through its paces.
I've got this flare going now. I'm going to open it up a bit more so you might get some drops in pressure.
How on earth do you get the coal burning in the first place?
This is the match. This is triethylborane. What we do is it ignites when it's exposed to air.
Here's how it works. It all happens underground, beneath the water table. The coal seam is ignited, and under high temperature and pressure, the coal reacts with oxygen and water to become a mixture of gases. The reaction is controlled by injecting more air and steam, so about a metre of coal seam is consumed each day. The resulting gas is sucked out through another pipe. UCG marries the mechanics of longwall mining with the chemistry of gasification.
It's very similar to longwall mining, except instead of having a machine underground, there's a chemical reaction on the face. And by putting the hot gases across the coal face, the coal effectively dissolves in front of your eyes and turns into this energy-containing gas.
The gas is called syngas, a flammable mixture of hydrogen and carbon monoxide. Every day, underneath this paddock, 150,000 tonnes of coal is being turned into gas.
It produces enough energy to run about 2,000 to 3,000 homes per annum if it were converted to electricity.
Injecting different mixes of steam and oxygen creates different hydrocarbons, making their underground reactor more like a chemical refinery than a power station.
To ensure that none of those chemicals escape out into the groundwater, we always keep the pressure a little bit below the pressure of the groundwater.
So if people say you're setting the earth on fire, how do you respond?
You just explain that you're setting the earth on fire 200 metres below a large wall of water, that the minute you stop breathing air on it, it will go out.
Although the different coal gas technologies compete for the same land, UCG targets smaller areas and thicker coal seams than CSG does.
We've got areas where we've got overlapping tenure with the underground coal gasifiers. Their process is much more condensed. They need much less area, whereas we drain sort of the whole countryside.
That's exactly what neighbouring farmers are worried about.
Our concern for the future is the impact of the coal seam gas extraction, which is taking water out below our aquifer. And some hydrologists are saying there's a link between our aquifer and the coal aquifer. The mining companies and the government are saying there's not. Who do you believe?
How would you respond to that?
At this stage, the science isn't indicating that that's the case. The water that we have trapped in the coal seams essentially is encapsulated. It has impermeable layers above and below that doesn't allow it to flow between seams.
So they're completely sealed off from each other?
Yes, yes.
But because UCG doesn't bring the groundwater to the surface, does that mean the locals are less concerned about it?
Well, yes and no. We don't have the salt issue, but with underground coal gasification, our issue is probably subsidence.
When a coal seam is removed underground, as UCG does, it can cause the rock layers above to crack and slump into the empty space left behind. That's been a problem with longwall mining in central Queensland and New South Wales, where croplands and rivers have been damaged.
Gasifying coal is easy if you can get the gases to it. The challenge has been about making sure we could manage the ground response and be sure that environmentally we are not causing any unintended impacts.
Unlike CSG, the Queensland Government has decided not to approve any new UCG projects until the existing ones can prove they're environmentally safe.
Coal seam gas is generally given priority at the moment.
And why is that?
because it's a more mature technology.
But the need to reduce greenhouse emissions from burning coal will change how power stations operate.
Queensland is drawing a line in the sand. Any new coal-fired power station will have to meet world best practice low emission technology.
If that means they have to gasify the coal to capture the carbon dioxide, UCG may have an advantage.
Most clean coal technologies rely on the gasification of coal. Typically they do that above ground. We don't need to mine the coal. We don't need to build an above-ground gasifier, so our capital costs are up to 50% lower. So given that the world will face increasing costs from carbon, UCG plays a key role in reducing our overall costs of electricity generation.
Next week on Catalyst, fighting fire with fire.
To burn or not to burn? Actually, that's not the question.
Knowing the enemy.
To find out how fire works, we put a bushfire in a box.
And decisions under fire. When this forest burned, firefighters had to make some quick decisions. Next week's special edition of Catalyst, In the Line of Fire. Well, that's it for now. Don't forget our website for more info on any of tonight's stories. And while you're there, why don't you participate in our fatherhood survey? I'll see you next time.